Hello, Stats 300. This is Professor Gonzalez, and I would like to do some problems from 7.4 homework on the interactive side. Once again, you can see it's the interactive side by this symbol and this symbol. This particular problem, when you see notation, of p hat, then you're talking about 7. This is 7.4. You're talking about this section 7.4 with the little p hats. You can see them right there. And the first thing you really want to do is you want to show that this stuff is true right here, right? Because once that is true, if this is true with our sample size and everything, then we're allowed to use the central limit theorem for sample proportions. Let's go see what this problem is asking us to do. It says withdrawal symptoms may occur when a person using a painkiller suddenly stops using it. For a special type of painkiller, withdrawal symptoms occur in 1% of the cases. Okay, now that right there, that's a proportion, right? That is a proportion. That is 1 out of 100, also known as 0.1 or 100th. Okay. And they didn't talk about any sort of sample up to this point. Reading up to this point, they did not talk about a sample, right? So that would be called your population proportion, which is P. So the population proportion is 0.01. If you read on, it says of the cases, consider a random sample. Okay, now we're talking about a sample. So when you read on, it says consider a random sample of 1,100. So n equals 1,100 people who have stopped using the painkiller. They'd like us to find some things. They'd like us to find p hat, where p hat is the proportion of people in the sample who experienced withdrawal symptoms. Okay, I'm sorry. They didn't want us to find p hat. They want us to find the mean of p hat. Well, finding the mean of p hat, that would be the mean of all the p hats, all these sample proportions. Consider a random sample of 1,100 people, but if you take this sample over and over again, you're going to get all these p hats. And what's the mean of that? It can be a little bit confusing. However, if we go to our formula sheet, it says as long as we can have this satisfied right here, right? So let's check that part out. That is saying, let's do an if statement, right? If n times p is greater than or equal to 10, and the second piece to that is if n times the complement of p is also greater than or equal to 10, then we get to use the central limit theorem, which gives us all those great formulas. So what is n? N is our sample size. So I'm going to put that in. N is our sample size. Our sample size is 1,100. Here also 1,100. And P is our population proportion, which is right there at 0.01. And when we multiply those two pieces together, we get 11, which is greater than or equal to 10. Check. So that part is satisfied. And this is 1 minus p. Well, 1 minus p is 1 minus 0.01, which just gives us 0.99. And when we multiply those two together, we get 1,089, which is definitely greater than or equal to 10. So that's checked. Therefore, we can use the central limit theorem. Awesome. Because the central limit theorem has some great formulas that will help us. It says, if you want the mean of the p hats right there, it's just equal to p, the population proportion. Oh, that was easier than I thought. If you want the mean of the p hats of the sample proportions, that's just equal to the population proportion. So that problem's done already. So this answer right here is the mean of the sample proportions is equal to 0.01. So part A done. Part B, find the standard deviation. Find the standard deviation for all these sample proportion or p-hats. Well, that sounds tough too, but now that we're allowed to use the central limit theorem, let's go down and see if we have a formula for that. Oh, yeah, we do. There it is right there. Right? So what does that formula say? It says the square root of p times its complement divided by n. So where am I going to put that? Let me put it right here. So if we want the standard deviation of p hat, or our sample proportions, that's going to be the square root of the population times 1 minus its complement divided by n. Okay, let's work that over here now. So we're doing what problem? Part B. And I might as well go back to red since that seems to be working for my standard deviation of the population proportions, or the sample proportion, rather, p hat. And that is just going to be the square root of this quotient p, which is population proportion 0.01, times the complement of p, which is just, you can see it right there, but it's 1 minus, so it's like $1 minus a penny, which gives us 99 cents, or 0.99, divided by our sample size, which is 1,100. All right, and when you take care of that quotient, multiply, and then divide by 1,100, you get how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros and a 9. And don't forget to take the square root of that. Don't forget to take the square root. So now we have the standard deviation of the sample proportion is going to be equal to 0.003, or 3 thousandths. And part B is now done. Part B is now done. There's my answer. And now let's do the toughest one, part C. So part C, where's the question? Part C, it says compute an approximation for, now this means probability. So this means probability. So we want to find the probability that the sample proportion p hats are less than 0.02. Wow, why did that just erase? Oh, and it just froze on me. Huh. Great. I'm not sure if I can get this to start back up again. Nope. There we go. Okay. All right, so just got lost in this. So we're basically trying to find the probability, which is going to be the area under the curve, that these p hats are less than 0.02. So and then it says, which is the probability that fewer than 2% of those sampled experience withdrawal symptoms. Okay. All right, let's draw a picture. So once again, the notation they're using is the probability that the sample proportions are less than 0.02. And my little picture that goes along with that looks something like this. once again, these are all of these sample proportions, right? A bunch of them. And when you take all these sample proportions, you make this normal distribution that has the mean of the sample proportions. And we know, oops, that's supposed to be a hat, p hat. We already know what that is. We did that up here, right? The mean of the p hats is 0.01. So this is just 0.01. And this notation is saying we're looking for the p hats that are less than 0.02. Now 0.02 is over here. Put it right there. I don't know exactly where it is. I don't have a great reference yet. Of course, when I turn it into a z-score, I'm going to have a much better reference on the scale of all this. But there's 0.02, and it says, once again, find the probability that the p hats or the sample proportions are less than. So less than is, of course, this way over here. Okay, all these guys over here. So the area under the curve to the left. Now, once again, these are sample proportions, and we need to turn this into a z-score. Well, the formula for z-score, if you haven't guessed where that's going to be, it's going to be right here under sample proportions, and there is our ability to turn our sample proportions into z-scores. So that formula, once again, is going to be your sample proportion minus the population proportion divided by the standard deviation of those sample proportions. So that's going to be z equals our sample proportion, which is right here, right? 0.02 minus the population proportion, which, right, we already had that way up here. Population proportion is 0.01. 0.01, yes, which is the same as the mean of the population of the p hats. That p hat is just looking too, there we go, is the same as the mean of the p hats. And we want to divide that by the standard deviation of the p hats, and we figured that out back here at part B. So that's just divided by 0.003. And when we put this in the calculator, we get approximately, we get a z-score that is approximately 3.33. Okay, so starting to run out of space here, but let's go ahead and write our new, right, same exact looking normal distribution, but now this is standard normal once again because it has a mean of 0. And look at the z-score way out here. I mean, if you're past 3, I mean, you really almost have nothing left. I'm probably not even far enough to the right. A z-score of 3.33, and we want to know this. Let's see if I can shade this. We want to know the probability that's less than, right, this 0.03, which we turned into a z-score of 3.33. So if I could figure out the area to the left of a z-score of 3.33, I've got my answer, right? So it's just this little bit. I don't want the little bit. I want everything to the left. That's going to be almost 100%. Let's look it up on the z-table. So positive z-table of 3, here's 3.3, and 3. So this is 0, 1, 2, 3, I believe. I think it's right here. Let me just double check. Yep. There's 3. If we go down here, right, there's our 3. Yeah. So a z-score of 3.33 gives us an area of 0.9996. And that is the answer to the problem. The question, what was the question again? Compute an approximation for the probability that these p hats or these sample proportions are less than 0.02 which is the probability that fewer than 2% of those sampled experience withdrawal symptoms. So we're trying to find the probability that fewer than 2% sample those sampled experience withdrawal symptoms. And that is going to be 0.9996. That's almost everybody. Okay, I hope that helped you out. And signing off, I will post more of these and pretty much have them done though, because I think 8182 I think just has maybe one on the interactive side. Once again, these interactive problems are the same ones that are on test part 2, and the assigned problems that I've been kicking out to you are on the test number 3 part 1. All right, well, I hope you